Hi, it's another nostalgic math ramble. We are still looking at the DBE's paper 1 from May 2023, and this is a question on patterns, sequences. Right, let's have a look. Question 2.2. An arithmetic and a geometric sequence are combined to form the pattern which is given by Pn is equal to x, a third, 2x, a ninth, 3x, a 27th, and so on. Write down the next two terms of the pattern. Okay, hopefully it's clear which one is arithmetic, which one's geometric. So they're alternating, right? So if you just look at the first pattern, which is x, 2x, 3x, right? That's an arithmetic series where we're adding x each time. Plus x, plus x, and so on. And then the second sequence is a third, a ninth, a 27th. Again, very useful to immediately see that, powers of 3. So as advised in another video, learn your powers, guys. It will change your life. So over here, we're timesing by a third each time. Right, so it's a geometric series where r is a third. Right, so write down the next two terms of the pattern. So the next term is part of the arithmetic series, so we're going to add an x. So that will be 4x, right? And then the term after that is part of the geometric series, where we're going to times a 27th by a third. So that is going to be an 81st, an 81th, right? Okay, easy enough, right? Yeah, easy peasy lemon squeezy. 2.2.2, there's nothing in this world that is easy peasy lemon squeezy, okay? If you want me to explain how I did any part of this video, please do not even hesitate one moment to leave a comment and X, and I will clarify. Right, determine the general term Tn for the odd terms of this pattern. So T1, T3, T5, so the arithmetic sequence, right? And we know that for arithmetic sequences, Tn is given by a plus n minus 1 times d. Okay, we know that a, the first term, is x, n is whatever position you're interested in, and d is the difference, which is x as well. So that's going to be x plus nx minus x. So that just ends up being nx. So you don't even need the formula. You could kind of see it visually, that term 1 is 1x, term 2 is 2x, term 3 is 3x, term 4 is 4x. So Tn will be nx. Right, and this is also, this is an interesting question, because I just sort of had a confusion of, well, but this is T1 and this is T3 and this is T5, but that is false. This is P1 and this is P3 and this is P5. And this question is not asking for a general formula for P, and in fact the general formula for P would be a piecewise function, right? Because for the odd terms it's following an arithmetic sequence, for the even terms it's following a geometric series. So we are not talking about n relative to the sequence P. We're talking about n relative to another sequence, a subsequence, which is this sequence. Okay, so that is why we're using n is equal to 1, n is equal to 1 for this term, n is equal to 2 for this term, n is equal to 3 for this term, not n is equal to 1, n is equal to 3, n is equal to 5. I hope that makes sense. I don't know if that was just a personal confusion. Anyway, right, time to shrink stuff. I made them bigger. right? So now we're asked to calculate the value of P26. So P26, that's a term on the even index, even position. So we're looking at the geometric sequence, right? And so what would be useful is for us to say let Gn represent the geometric sequence, right? The subsequence, if you can call it that. So then we know that Gn is given by A times R to the n minus 1, where the first term of the geometric sequence is a third, and R is also a third, n to the minus 1. So this is a third to the 1, essentially, right? So if we add those powers, we're going to end up with a third to the 1 plus n minus 1, which is just a third to the n. And again, that's pretty clear. This is a third to the power of 1. This is a third to the power of 2. This is a third to the power of 3. So this formula makes sense, right? Whatever position the term is in, we just raise a third to that number and we get the value of the term. So now we're asked for P26, and P26 is the 13th term of the geometric sequence, right? Because term 1 is P2, term 2 is P4, term 3 is P6. So if we're looking for P26, we're actually looking for G13, the 13th term of the geometric sequence. So P26 is equal to G13, which is a third to the 13, whose value I have no idea. Oh no! Oh my goodness, what am I doing? Oh dear heavens. Yeah, so we end up with a very tiny number. Okay, and that is the value of P26 according to myself. Oh no. Oh, tragic, 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 tragic. Oh. Did it. Succeeded. This is question 2.2.3. Okay, and then the last question, 2.2.4. If the sum of Pn from, so the first 21 terms of this joint sequence, okay, Pn, gives us 33.5, determine the value of x. Okay, so what we need to recognize here is that the sum of Pn, the sum of the first 21 terms, is the sum of the first 11 terms of the arithmetic sequence and the sum of the first 10 terms of the geometric sequence, right? Because if we're adding up the first 21 terms, remember term 1, term 3, term 5, blah, 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 up until term 21, those are all arithmetic, right? And how many of them are there? What's an easy way to figure that out? Well, you could just say 1, 3, 5, 7, 9 is 5, 11, 13, 15, 17, 19 is another 5, and then plus 21 gives you 11, right? So that's, I think, a quick way to figure that out. And then the 2, the 4, the 6, up until the 20, those would all be geometric terms, right? So, and I think it's easy to see there that there are 10 of these, but again, you could kind of reason about it the same way with the previous one, right? That's 5, And then 12, 14, 16, 18, 20, that's another 5, so there's 10 of them. Okay, so that's where these numbers are coming from. Right. So let us add, man. So we know the formulas for arithmetic series and for a geometric series, right? We know that for an arithmetic series, we have, I'm just going to write it down first and then replace the variables. 2a times, no, I'm lying. It's like something looks off. So it's n over 2 times 2a plus n minus 1 times d, right? That's for the arithmetic series. And then for the geometric series, it is a times r to the n minus 1 divided by r minus 1. Okay, so now let's replace these with the values. So for the arithmetic one, we have here 11 terms. The a is x, okay, n is 11, and the difference is x. Okay, and then for the geometric one, the first term is a third. The r is also a third. Okay, and then in the denominator, likewise, we replace the r with a third. So let us simplify. So then we have 11 over 2. Here we have 2x plus 10x. And then down here we have a third. Let's just keep this in here. So this could actually just be, we could say this is 1 to the n divided by 3 to the n, just because I'm lazy to write the brackets. Down here, this would become negative 2/3. Okay. And then we have 11 over 2 times 12x. And then over here, we could decide what we want to do. So we've got plus a third divided by 2/3 is the same as a half. So this is the same as 1 times 1 to the n is just the 1. So that's a 1. This one will remain a 3 to the n. And then at the bottom here, we'll have a minus 2. We could actually use this minus to do a switcheroo. And if you're not sure why that works, there is, go and watch the first video in this series where I explain why mathematically that is true. So I am going to do that quickly. Right. Oh my goodness, and I haven't been replacing the n. Oh, the agony. We do know what n is. N is 10. We have 10 geometric terms. Okay. Watch me weep. Watch me nay-nay. Right. Almost there, guys. Okay, so over here, 11 over 2 times 12x. The 2 is going to go into the 12 6 times. So we're going to end up with 66x. So if you multiplied it out, 12 times 11 is 132. And then the x, and then you divide that by 2, that gives you 66. And then over here, we have, we can just halve both these terms. So we're going to have a half of 1 and then a half of 3 to the 10, 1 over 3 to the 10. Okay, anyway, and we've been told that, oh, yeah, I think we need to shrink some of this. There's a lot that happened here. There is a lot. There is a lot. Okay, so heading right back up here, we were told that this sum is 33 and a half. We then went to the excruciating pains of figuring out an expression for the left-hand side, which came down to 66x plus a half minus a half of 1 over 3 to the 10. And we found that that was 33 and a half. Yes. So now we want to solve for x. So we are going to rearrange our equation. Right, and then divide both sides by 66. Notice how I am avoiding with all my might having to put this into the calculator. If I'm putting it into the calculator, I want to put one jumbo thing into the calculator. Thank you very much. I don't know if teachers recommend my ways. I don't think they do. If you're going to work out as you go, I would say, though, it's very important to work with accurate numbers, so don't round off while you're doing workings, because then you might end up at a very different train station. So make use of your calculator storage facilities and goodies like that. Right, so we then get x. X is 0,500001283, right? X is something very close to 0,5. And of course, if you wanted to check this, if you had a bit of time in your exam, you would then go right ahead and pop that little x into the sequence you were given, right? Put it in over there, work out what the first 21 terms are, and then see if they do add up to 33 and a half. Okay, so first let's see if this answer is correct before I begin my sermon. We do end up with x is equal to a half, which is perfect. They say it is equal to a half exactly. Why am I struggling to believe that? Yeah, I think it's rounded off. It is extremely rounded off. Right, so I think the big takeaway for me from this exercise is it's so important to be comfortable manipulating algebraic expressions. So getting this huge expression involving fractions and, sometimes multiplying out things and all sorts. So if that's something you're not very comfortable with, you only get comfortable with it with practice. So practice it. Scour through your textbooks, find exercises with nice big bombastic expressions that require you to simplify them to like 1 or 2 terms. And then when you're faced with a question like this, it's not so daunting. I think it's also important not to try to do too much at once. In one step, focus on one thing instead of trying to do the switcheroo and multiply out and divide the 2 into the 10 and just one thing at a time. If it ends up taking a whole page of workings, it takes a whole page of workings. That's fine. That's fine. Anyway, see you for the next one next time.